Azure Kubernetes Service is Microsoft managed container orchestration platform that simplifies deploying, managing, and scaling containerized applications using Kubernetes. It handles the complexity of Kubernetes infrastructure, so teams can focus on building and running applications, not maintaining clusters. In this video, we will walk through the deployment process and various security elements that you need to consider while deploying AKS. You can search for Azure Kubernetes Service in the Azure search bar and create Azure Kubernetes cluster. In the basic tab, from security standpoint, there are few settings that you need to be aware of. Automatic upgrades, when enabled, keeps the control plane updated with latest security or bug fixes. Node security channel type options defines how security updates are applied to your worker nodes in the AKS cluster. There are 4 options here. Node image is the selected option here. Node image option is the recommended option for most users. When you select this option, Azure fully manages and applies weekly security and bug fix updates using a new pre-patch node image. This option is great for production environments where you want continuous security without manual effort. Other options are none, unmanaged, and security patch. For authentication and authorization, options such as local accounts with Kubernetes are back, uses Kubernetes native role-based access control. Users authenticate using local admin credentials or certificates. And access control is handled using Kubernetes roles and role bindings. This is not recommended for enterprise use due to lack of identity integration. Options such as Microsoft Entra ID authentication with Kubernetes are back. Authenticates users using Microsoft Entra ID. This option still uses Kubernetes RBAC for authorization. This option is best for organizations wanting identity federation but still managing roles using native Kubernetes tooling. Options such as Microsoft Entra ID authentication with Azure RBAC uses Microsoft Entra ID for authentication. Uses Azure RBAC for authorization, meaning role assignments are managed in Azure rather than inside the cluster. This option simplifies access control across teams using centralized Azure role assignments. This is ideal for enterprise and production clusters with strong governance needs. Now click Next. In the node pool, you define how your AKS nodes, the virtual machines that you run your container workloads, are configured and scaled. A node pool is a group of VM instances within your AKS cluster that share the same configuration. You typically have system node pool and user node pool. System node pool runs core Kubernetes components such as kube proxy or core DNS. User node pool runs your application workloads. Enable virtual nodes when checked, meaning virtual nodes are enabled via Azure Container Instances. This option allows burst capacity for sudden workload spikes without provisioning extra VMs. This is great for cost efficiency and elastic scalability. Node pool OS disk encryption uses platform managed keys for disk encryption in this case. This means the node OS disks are encrypted at rest using Microsoft managed encryption keys. You can optionally use your own customer managed key via Azure Key Vault for added control. Now click Next. In the networking tab, enable private cluster limits API server access to within your virtual network and improves security by disabling public API access. Public access allows access to the API server from specific IP ranges. In the container networking, Azure CNI overlay, if selected, Pods gets IP from a private IP space. This is great for scale and easier IP management. And Azure CNI Node subnet when selected assigns pod IPs from your virtual network. It is more traditional but can consume IPs quickly from your network. In Bring Your Own Virtual Network section, you can use your own virtual network to host AKS Cluster. Cluster subnet is for hosting control plane and virtual node subnet is for worker nodes. Make sure that both are different subnet. On the screen, I wrongly selected same for both. In cluster ranges and DNS section, Kubernetes service address range is the internal IP range used for cluster IP services. DNS service IP address indicates internal IP for Kubernetes DNS. And DNS name prefix is the prefix used to generate your AKS cluster's public AQDM. In the network policy, you have three options. These options controls traffic between pods. None means no network restriction. Calico enables Kubernetes network policy for granular control. And Azure Option is the simpler solution managed by Azure for basic restrictions. Load balancer standard is selected and it is recommended for most workloads for better performance and scale. Now click next. In the integration section, Azure Container Registry connects your AKS cluster to a selected Azure Container Registry and enables seamless image pools for container deployments from your private registry. Service mesh manage traffic between services and enforce security and observability. It also enables advanced routing and resilience without code changes. And Azure Policy allows you to apply governance and compliance rules to your AKS cluster. Now click next. In the monitoring tab, Container Insights enable container log monitoring via Azure Monitor. It requires linking a log analytic workspace and collects CPU, memory, and pod container logs. It controls log collection frequency and retention as well. Manage Prometheus collects metrics from workloads. It is great for tracking performance at the container or pod level and integrated with Azure Monitor and requires a dedicated workspace. Manage Grafana provides visual dashboards for Prometheus metrics and it is fully managed by Azure. No self-hosting required in this case. Alerts enable recommended alert rules and alerts are sent to the specified email. Click next now. In the security tab, Microsoft Defender for Cloud provides unified security management and threat protection for your AKS cluster. OpenID Connect enables OIDC Issuer, which allow AKS to use token-based authentication for pods. It is useful for secure identity federation with Entra ID and workload identity. Workload identity integrates Entra ID with Kubernetes workloads. This option securely assigns identities to pods so apps can access Azure services without storing secrets. Image Cleaner automatically deletes unused container images from the AKS node disk. It helps improve security and performance. Azure Key Vault CSI driver lets pods securely access secrets from Azure Key Vault using a CSI volume mount. This is ideal for apps that require sensitive credentials. Now click Review plus Create. And your AKS cluster will be deployed. So there are a number of key takeaways for maintaining AKS security. And that's why understanding them is crucial. Key best practices includes enabling private cluster access to restrict API exposure, using Microsoft Entra ID with Azure RBAC for centralized identity and access control, and applying network policies to secure pod-to-pod communication. Enabling workload identity with OIDC removes the need for secrets by securely binding Azure identities to pods. Integrating with Microsoft Defender for Container adds threat detection and runtime protection, while ACR and Image Cleaner help reduce risk from outdated or unverified containers. You can also achieve additional security through disk encryption, Key Vault integration for secrets, and Azure policy for enforcing consistent governance across the cluster.